All right, a real quick video here. I'm about to do a base cut on this 372 clone for a customer. And one thing you always want to do is make sure that the cylinder is square to the bore, right? So a lot of guys cut these mandrels. I cut them. I've got them out of ultra high molecular weight UMHW plastic. I've got some out of steel. I've got some out of aluminum. It's just sort of whatever I had on hand, what I needed that size. So I do that. A lot of guys will take a mallet without the cylinder on. They'll chuck this up in a 3-jaw and they'll go through with an indicator and check it. Every time I chuck up a mandrel, they're never true. So what I actually do is I take a knurling pin and I bring it up on the very edge and I bring it in real nice and slow just until it touches it, and I let it feed into it nice and easy until it stops wobbling. And that's how I true up the mandrels when I chuck them. I'm sure the machinist just cringed, but the other thing that I do to check and make sure, so I have my dial indicator down here. It's on this corner of the tool carriage, or the whatever you call that. Yeah, we have our indicator down here. So what I'll do is I'll come over here and I get as close to the middle as I can because that tends to be the most consistent spot. And I will actually bring my tool up to where it touches. And if you look down here, you'll see we're actually a little bit off 0. I know that angle's funny, so I'll set it to 0. And then what I will do is actually back it off, rotate the cylinder 90 degrees, back in. Still on 0. Do it again. Another 90 degrees. Okay, we are shy a thousandth of an inch. Do it again. Now we're shy 2/1000ths of an inch. So on these Chinese cylinders, that can be as much as, well, see there, we're still 2/1000ths of an inch. So that could be as much as the setup as it is anything. If I'm off like that, 2/1000ths of an inch, especially on these Chinese cylinders, sometimes I will say that's the base being warped. That is what it is. The other thing I'll show you, get you in here so you can take a look. In fact, I'll probably just go ahead and show you the base cut as I do it. So you'll see in here, we've got our base. We're running at an angle, check and make sure everything clears. This is tight. All right, I actually put a little sacrificial piece of aluminum up in here just so I'm not knurling into anything. When you're checking this, you want to make sure, because if you're like me, you've already done your band cuts, so you've got witness marks here from your nuts. You want to be mindful of that when you're doing this as well. So I believe we're square enough to start. I bring it up to 0 and I do a pass. And I come back out. All right, now we turn it off. So if you look here, you can actually see, okay, we've got machine marks consistently and evenly all the way across. So we will say those 2/1000ths that we saw was a measuring variance. All right. The reason it cut at technically 0 is because when you take the tooling and you're pushing it up till it stops against something, even if you just bump it in there, that is in the interference realm of where it's still going to cut and skim. And that is a nice, pretty cut. I mean, it'd be great if we could call that good, but we can't. So, do 10/1000ths. Might be a bit much on this cylinder. Sometimes you only take 5. Speed is a critical factor when you're running your tooling in and out like that. And I'm saying this as an amateur machinist. So you can see the finish there. I'll run this one in a bit faster so you can see a difference in machining. So that one was quite a bit faster. It actually pushed the tooling back out 2/1000ths because when I'm just doing these meaty runs, I don't lock it down. I do for the final runs. So you can see it's a different finish on the cut surface of the cylinder. Go up to 30 thousandths. Now on this saw, I did a 40 thousandths band cut. So my process is to, when I do a band cut, I go ahead and automatically do that much on the base too. I've yet to find a saw that, especially when you're running a base gasket, needs less of a base cut than it does a band cut. So I'll set it to 40. I actually lock the carriage in on this cut. If I'm really particular about the finish, I'll actually put a 4mm hex into a drill, and I'll run this with the drill really steady and let it go in nice and slow. I have a suspicion that with a gasket on this saw, we're going to be coming back and taking another 20 thousandths off. But I don't know. You always want to be sure and check. Measure twice, cut once, right? All right. Steady pace until chips aren't coming off anymore. The light out of the way. All right. Let me bring you over here and we will check the squish measurement and then come back and dial it in. It's that sacrificial piece of aluminum puck that I keep in there. I also stick a little cut of rubber in there. It doesn't take up the full diameter, but you know, if you put enough lateral pressure on the tailstock, that locks it in place. Show you the band cut here. Oh, I held in a sneeze. That was bad. This band actually had a bunch of chrome up in it, so cutting through it was bad. That's why you see that ring right in there on the inside. So let's go check squish. All right, so we are going to go ahead and put on our base gasket and our piston so we can check our squish. Should I have done that already? Probably. Anytime I'm putting a base gasket back on a used saw like this, especially one that's getting a full rebuild, and partly because it just makes it easier for me when stuff's going on and off, I will add a small thin layer of Durco. Not necessarily for sealing, although it does help in that regard, but because pulling gaskets on and off is frustrating, it's sometimes not good for them. They like to tear. So just a small layer of Durco under the gasket will hold it in place, will help make sure it's sealed up in the event that there's a deformation or a not good part of your cases. This saw is getting a highway gasket seal set, if you're into that sort of thing. And it's actually getting just a Duke's aftermarket top end. So that's nothing particularly fancy. Oh, okay. Ooh, you'll have to excuse the noises coming out of my face. I see a lot of guys saying these aftermarket circlips fail. I have primarily used them and they've never been an issue for me in my experience. Your mileage will probably vary, as all mileages tend to do. So if you feel uncomfortable running aftermarket parts, then maybe don't run aftermarket parts. There we go. Okay. So we've got a 40 thousandths band cut, a 40 thousandths base cut, an aftermarket piston with a gasket, and a set of XT cases. So if I were to guess, I would be inclined to think that the squish at this point is going to be in the neighborhood of 50 thousandths. I would be shocked if it's under 40, just based on my experience doing these. So for this first run, we'll throw in 2 bolts, because that's all you really need for this. sure it sits down square. This is the part of the game when oftentimes if you haven't done a good job of going ahead and cutting your skirt extensions, that becomes an issue here. And you can kind of feel it when you haven't, when that's the issue. Okay. All right. Let me grab a flywheel to spin this thing. OEM. All right. So for these first runs, what I like to do is take this thicker solder. You can actually see the end there where it's already been touched once. So, you know what? We'll just fold it over. We'll cut it off. We'll be the responsible adults and give it a snip. This stuff is 25, 50, go out to 75 thousandths. This stuff before compression is 50, 62 and a half, 63 thousandths. So all the way in until I feel it touch the other side. Come up to the top dead center, give it a little back and forth like you're happy to see it. So we didn't take a whole lot of squish out yet. We've got more to go. 0, 25, 50, 60. Well, wouldn't you believe it? 49.92. We'll call it 50 for good measure. So, most every saw, if you target 20 and you get within 10, well, you don't want to be at 10 thousandths. But if you're under 30 for a work saw, you're probably all right. Get those bolts back out so we don't lose them. So 50 thousandths, we want to shoot for 20. We'll probably go ahead and take another 25 off and let that last cut be really slow, just because that tends to take a bit more. So we'll do that. We'll come back and we'll check it. Okay, so we're back over here at the lathe. Rubber insert into the cylindre. The pi r squared device fully on. Don't forget our puck. One turn. That was 2 turns. I can't count. I didn't need that anyway. And it's gone forever. Okay. So this is still locked in, just as an example. Still at 40 thousandths. I would actually be inclined to say that's fairly close. Normally, I come back over and reset my indicator to 0, just because that rubber in there, and I would feel more comfortable going through and indicating again. So that bumped in 2.5 thousandths. So we're going to say it's still at 40,000. Turn the light on so you can see better. Yeah, you like that. Okay. So we're at 50. We want to be 20, 22, 24. I'm more comfortable at 24, knowing that this saw is going to a guy who probably runs Husky or Steel at 50 to 1 and runs the chain till it's breaking without sharpening it. So, plate on, indicate the 50. I didn't miss any steps, did I? Are you checking my work? Alright. Indicate the 60, so that's an additional 20 thousandths off. That should get us to 30 thousandths squish. It's helpful to do basic math in your head as you're doing this process. Alright, so this is where we start to get real particular. Alright, so we want to target 22, 24. So we will take another 5 off here. We know the machine can take another 6 off, or 7 off. What I like to do on these last passes to give it a nice, clean finish and a really stable flat cut is take them smaller. So this is at 40, this is 65 thousandths total cut. Just going real slow, letting the tooling do its job. Trying to be as consistent on my feed rate as possible. If you can see that, you'll notice there's far less chips coming off on the return pass this time. That's a result of going slower on the way in. All right. Let's take another 3 off. Go the right direction. That's 68 thousandths total cut. That should get us to 22 thousandths squish. All right. So we did a total 68 thousandths base cut, 40 thousandths band cut. Our numbers are probably going to be less than ideal. I'll bet our transfers are in the range of 130 or so. Our exhaust is probably close to 110. I dropped my puck. Found my puck. All right, let's blow this off and go measure it out. Okay, same process here, except we're going to be a little bit more particular about our squish measurement. I keep greasing a bucket with a brush. You should too. Little dab here, little dab there. Now I grab some thin stuff. Sorry to block your view. I usually keep most of that over there. I don't work with cameras in here much. You guys are weird. That's why you fit in. So this is some smaller stuff, some 1/32 inch solder. I don't think I've ever measured the uncompressed width of it. So out of curiosity, 31 thousandths. Okay, so we cut us off 2 pieces here. Drop it on the counter so I can never find it again. Well, I didn't mean drop that piece. If you go to buy this stuff and you can only find it in the tube coiled up like this, do it, but those coils are annoying. I'm not a fan, to be truthful with you. All right, the biggest thing, especially when you're doing squish measurements, is you want to get them as far out as possible. If you're measuring squish on a stock saw like this, typically the bands will have a lip way out here on the edge of the bore where it's tightest, and that's really tricky to measure. Sometimes the best way to get that number is to shove solder through like you saw here a little bit ago. But when you've got a nice flat band cut and you know it's parallel to the bore or perpendicular to the bore, you can get away with a bit of a different method like this. All right, bolts in place. Try not to disturb our solder as we come down. Start one, start the other, and sink it, and sink it. All right, TDC. You really don't want to be using super big solder that you've got to get a wrench on here and crank on it. The more you compress that stuff, the temperature that it's at, all of that will affect your reading. So this isn't by any means a true measuring of squish, but it is a useful and typically reliable method for our purposes, for what I'm doing here. So I'll rock it back and forth till I'm happy with it. Just out of curiosity, we'll spin it all the way over. I'm going to have to actually shave a little bit off this side of the transfer tunnel because it's hitting the flywheel. You believe it? Okay. What you don't want to do here is drop the piston and lose your squish. It's not on the piston anymore because they're both hiding out up in here. All right. 2 pieces of solder in my palm. Just set them here on this nice envelope. All right. So we know it's less than 31 thousandths. We'll go out to 25. Remember, our target was 22. Actually, make sure the solder's inside of it there. All right. So this is an interesting scenario where we have found ourselves that we overshot. Now I might go back and edit this together and find out that I just can't do math. We were at 50. We took another 28. It's 50 minus 28 is 32. We were at 40. We went to 68, which means we took another 28 out of squish. 50 minus 28, it's 22, yeah. So this is one of those examples of when you're not a particularly trained machinist, things can go wrong. Now, fortunately, I've got a thin gasket in here. We need to add in a minimum of 5 thousandths back to it. We can add a thicker gasket, or we can chuck this back up and add another 5 thousandths out of the band cut. We only did 40, so that might actually be what we go and do. So there you go. That's how you measure squish, cut a base, and plan to correct the errors that you made in cutting the base. Thanks for watching.